Picture a planet where the mountains don't just erode. They melt. Not sometime, not eventually. Right now, every second on one specific stretch of rock, roughly 500 light years from where you're sitting. Astronomers named it Corot 7b. But forget the name. Focus on the physics, because this thing breaks almost every rule you think a planet has to follow. Here's how we even found it. A French-led space telescope called Corot spent years staring at distant stars, watching for the tiniest dip in brightness, the shadow of a planet crossing in front of its sun. In 2009, one of those shadows revealed something astronomers had never confirmed before: a planet with both a measurable size and a measurable mass, small and dense enough to be genuinely rocky. Not a gas giant, a real, solid world, just like the one under your feet. Except nothing about it is like the one under your feet. It's orbiting its star so closely that one full trip around, its entire year, takes 20.5 hours. Not days, hours. This planet finishes in orbit faster than you could binge a single season of a TV show. How close is that, really? Corot 7b sits about 2.5 million kilometers from its star. That's roughly 23 times nearer than Mercury sits to our sun. And Mercury already gets scorched. This planet is basically pressed against the surface of a stove. Being that close comes with a price. Gravity has locked the planet in place. It doesn't spin freely anymore. It's tidally locked, the same way our moon always shows Earth one face. One hemisphere of Corot 7b lives in permanent daylight, forever facing the star, never once turning away. Now here's where it gets disturbing. Right under the star, at what astronomers call the substellar point, models put the temperature above 2,000 degrees Celsius, well over 4,000 degrees Fahrenheit. Hot enough to vaporize steel. Hot enough that solid rock simply stops being solid. The ground melts. Not lava rising from volcanoes underground like on Earth. This is different. This is the surface itself, silicate stone, turning into a standing ocean of liquid magma, because the sky above it never stops burning. Researchers studying Corot 7b believe there's a genuine magma ocean sitting across that dayside. An entire sea of molten rock, glowing under a star that never sets. No waves in the way you'd picture waves. No shoreline. Just a slow-moving, radiant sea of liquid stone, stretching out under a sky that's essentially one enormous furnace door left permanently open. Now, flip to the other side of the planet. Because it's tidally locked, the far hemisphere never sees that star. Not once. Not ever. With no thick atmosphere to carry heat around the planet, that night side isn't just cold. Estimates put it near minus 220 degrees Celsius, close to minus 370 Fahrenheit. Colder than anywhere on Earth. Colder, by a wide margin, than Pluto. Same planet. Same rock. One side hot enough to melt steel. The other side cold enough to freeze nitrogen solid. That alone should make Corot 7b one of the strangest places we know of. But it gets stranger. Corot 7b doesn't really have an atmosphere. Not one you'd recognize. No oxygen. No nitrogen. No water vapor drifting overhead. Instead, extreme heat boils rock itself into gas. The thin haze above that lava ocean is made of vaporized minerals, sodium, silicon monoxide, vapor that used to be solid stone. And vapor made of rock behaves the way vapor behaves. It rises off the molten ocean, drifts toward the cooler regions of the planet, and starts to cool. When it cools enough, it doesn't rain water. It condenses. It solidifies. And scientists' models show it falling back to the surface as fine mineral particles, substances with names like enstatite, corundum, and wollastonite. Rock rain, falling from a mineral sky, onto a world split between fire and ice. Researchers modeling this atmosphere compare it to Earth's water cycle, except every stage is built from stone instead of water. Evaporate, drift, condense, fall. A weather system with no water anywhere in it. And Corot 7b isn't even alone out there. The same data that confirmed this planet also revealed a second world in the system. Corot 7c, roughly 8 times Earth's mass, orbiting a little farther out. It never crosses in front of its star from our angle, so we've never actually seen it, only felt its gravitational tug. A whole sibling planet, known only because of the way it makes its star wobble. Here's the part that should really sit with you. When Corot 7b was confirmed back in 2009, it was a landmark moment. The first time astronomers had measured both the mass and the size of a genuinely rocky world beyond our solar system. Before this discovery, almost every confirmed exoplanet was some version of a bloated gas giant, easy to detect and nothing like home. Corot 7b changed that. It was proof that solid Earth-sized planets really exist out there, not just gas giants. The first real evidence that somewhere among all those distant stars, worlds made of rock and metal, worlds built the way ours was, were actually out there waiting to be found. But Corot 7b turned out to be nothing like Earth. It turned out to be a preview of something else, an entire new category of world. Because since 2009, astronomers have found more of them. Lava worlds. Kepler 10b. 55 Cancri EK 2-141b. Planet after planet locked so close to blistering stars that their surfaces sit permanently, partially, or entirely molten. Some of them are now priority targets for the James Webb Space Telescope, because studying their glow is one of the only ways to understand what a planet's interior looks like from the outside. Corot 7b wasn't a one-off freak. It was the first confirmed member of a class of planets that might be common across the galaxy. Worlds where rock doesn't just sit there. It flows. It evaporates. It rains. And researchers are still arguing over the details, right now, in current papers. How deep does that magma ocean actually reach? A thin, molten skin, or something extending miles into the planet's mantle? How much of that heat comes purely from starlight? And how much comes from the planet being squeezed and flexed by gravity itself, the same way Jupiter's moon Io gets tidally heated into a volcanic nightmare? Those questions are still open, still being modeled, still unresolved. What isn't up for debate is this. Roughly 500 light-years from Earth, there's a world where the ground obeys two completely different sets of physics, depending on which side you happen to be standing on. Molten stone under a star that never sets. Frozen stone under a sky that never sees light. Somewhere between those two extremes, there's a twilight band that's neither fully one nor the other. The only strip on the entire planet where temperatures might sit anywhere close to something survivable, and even that is still just a guess. Same planet, two different universes, one impossible border between them. If you thought rocky planet meant something familiar, something Earth-like, something almost livable, Corot 7b is the planet that proves you wrong. It's a reminder that rocky and habitable are two completely different words, and the universe is not shy about proving the difference. Follow for more real planets that sound like science fiction, because the universe keeps outdoing anything we could make up.